Okay, so these are the 4 levels of confidence we're going to be using. Again, 90, 95, 99 we used last year in Algebra 2. We're adding 98 this year. Those are the z-scores that are associated with these levels of confidence. That's going to be very important for today's lesson. Okay, so now we're going to estimate a proportion. So remember, we're using the word proportion here. So think about a fraction, a percentage when you get a test back. We're going to be doing percentages, a proportion of the amount. Okay, so before calculating confidence interval for a population proportion, you should check 2 important conditions. Random. The data must come from a random sample of the population of interest. So it has to be random. Also, what we've already done, the large counts check. We've already done this before. Both n times p, remember p is, you go to the dollar store and you buy your candy, and n times 1 minus p, that's your change you get back, are at least 10. So remember, you buy a 35-cent piece of candy, that's your p. Your change back is 1 minus 35 cents, which is 65 cents. So 0.35 and 0.65, 0.6 and 0.4, 0.2 and 0.8, and so forth. You multiply those times n, how many subjects are in the study, and as long as both of those numbers are greater than or equal to 10, we're good to go. So, problem. Random sample. Right off the bat, that's important. Okay? We know it's random. As long as it's random, we're good to go. Now, it says, of the 227 sampled, 84 said they had allergies. Okay? So 84, remember the fraction bar means out of, 227, that's your proportion. 84 out of 227. That's your percentage we're going to figure out. If you calculate that, you're going to get 0.37. That's our P. So P equals 0.37. 1 minus P, okay, if I buy 37 cents worth of candy, I'm going to get 63 cents back in change. The rest of the question says, check if the conditions are met. Okay. All we have to do is take the 227 n times our candy and our change. As long as both of those are greater than 10, we're good to go. Well, here we get 83.99, and here we get 143.01. Both of those are greater than or equal to 10, so yes, we're good to go. Check mark, met, yes, anything like that. So it met 2 conditions. It was random, and it met the large count requirement. Speaking is hard sometimes. Okay, the rest of this is just reading right here. So, you already know the confidence intervals are made up of 2 parts. There's the point estimate plus or minus the margin of error. So, here's the formula. I won't say it's a new formula because this is the formula we used last year and last week for this part. So the standard deviation of the sampling is square root of p times 1 minus p over n. When the large count condition is met, the sampling distribution is approximately normal. According to the empirical rule, p hat will be within 2 standard deviations, about 95%, in about 95% of all samples. All right? Therefore, in about 95% of the samples, p will be within 2 standard deviations. If you go back to the chart I just gave you, we said 95% was 1.96. That's approximately 2. Very specifically, it's 1.96, but it's approximately 2. All right. Finding the critical value. So the critical value is a multiplier that makes the interval wide enough to have the stated capture rate. So it says illustrate a 95% confidence interval. Okay, so just do your best to draw a nice little normal distribution. Now, it says, right, 95%. We said it's within about 2 standard deviations. Okay, so you count out plus 2, and technically it's a little bit short of that. Okay, and it's this area here. Technically it's negative 1.96 and positive 1.96 based on our chart. Rounded about 2 to negative 2. That's about 95% of the curve right there. Technically 1.96 to negative, but approximately 2 to negative 2. Yeah, we're going to do the same thing with 90%. Okay, we said 90% was 1.65. That's going to be a little bit more of an estimation. So here's 1, here's 2, 1.5 is about here, so go a little bit past 1.5 and negative 1.5. And put negative 1.65 and positive 1.65. I'm not going to measure, but that's about generally how much is covered in 90%. And then for the last one, wow, that was weird. For the last one, we had 99%. Well, 99% is 2.58. So we're going to go out 1, 2, here's 3. So 2.5 is right about there. So, I mean, this is almost the whole thing. I mean, there's only a little bit of space there. So again, that's negative 2.58. We're just estimating about halfway, 2.58. That's supposed to be 5. And that's about what it would look like. Okay? Okay, not measuring. Now, what does that come down to for the end? There's the formula we had from last year. So we have our point estimate, which is our p-hat, plus or minus our margin of error. How do we calculate the margin of error? We take the z-score times the standard deviation. And we're going to do that in a couple problems right here. And then we're done. All right. So, in a survey, we have 786 out of 2538 respondents. If we divide that, we have 0.31. So we're going to just fill in the formula. The formula is p-hat, 0.31, plus or minus the z-score. Now, what's the z-score for 90%? 1.65. Very good. So we put 1.65 here. We put our big old square root. We're going to put our candy price, 0.31. And then we're going to put the change, 0.69, divided by n, which is 2538. Now, I personally, here's how I do it on the calculator. You can do it any way you want. Here's what I do. See if I can access the calculator. I like to do it this way. I like to do baby steps. I don't like to have too many parentheses going on. So I first do second square root. And I type in 0.31 times 0.69 divided by 2538. I get that real tiny decimal. That's this right here. Okay? Now, whoops, I'm going to take that and just do it times 1.65. Again, this you don't have to do it this way. I like to do some baby steps. And I round. So that's about 0.02. Why am I going 2 spaces? Because my p has 0.31. So that's going to be 0.31 plus or minus 0.02. Point estimate error. Margin of error. What's that going to give me for a range? 0.29 to 0.33. And now we have our statements that we use over and over again for this one. And we say, this is one you just got to get used to practicing. We are. It's our first word. We are. And we said 90% confident. The interval from 0.29 to 0.33 captures the true proportion. And then this is when we just look back at our problem. What's it capturing the proportion of? So it's taken all together. How would you say things are these days are? And it says 786 respond they're very happy. So the true proportion of people who answered very happy. That's it. So we are whatever percent confident the interval from blank to blank captures the true proportion. That's the same every time. And just go back to your problem, your story problem, and just kind of capture the basic gist of it. That's it. Very happy. Okay. According to the Annenberg Foundation, now this one's different. Did they tell us the number of people? No, they did not. They just straight up gave us the percentage. It's 0.36. So we know in this one already p hat is 0.36. They just give it to us. Okay? So my formula is 0.36 plus or minus. Now it says it wants a 95% confidence interval. 95% is 1.96. And then we do this big square root, fraction bar. Price of the candy was 0.36. My change is 0.64. And I put on the bottom 1416. Personally, I will take that and do square root of 0.36 times 0.64 divided by 1416. I will get this teeny tiny decimal, which multiplied by 1.96 gives me, drum roll please, 0.03. Okay? So what's my range? From 0.33 to 0.39. And then we're going to write that same sentence. We are 95% confident that the interval from 0.33 to 0.39 captures, oopsie, I can spell, really can't, captures the true proportion of, and then we just go back to our problem, adults who could name all three branches of the government. And that's all you do. That's it. Could name what? All three branches. No,
not sure what happened to the report.
Oh, it is. It just disappeared.